Alright, today we're going to talk about similar polygons, and this is Unit 6, and this is Goal 1. So yesterday we went over ratios and proportions, and today we're going to actually use those concepts throughout, so this will be a goal that's tested on, and we'll be able to see and check for your understanding of ratios and proportions based on how you do on all these goals, since we'll be using that throughout. So we're going to talk about similar polygons. Similar polygons, as we saw in our discovery task, is that similar polygons have the same shape, but they're not the same size. They also have equal angles. So the angles are what makes the sides, or makes it the same shape. But the sides are proportional. So that's what this is talking about. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. And we could read that backwards. If corresponding angles are congruent and sides are proportional, then the two polygons are similar. So what we see then when we were talking about congruent polygons, those had the same lengths on the sides because they were the same size and shape, and then the same angles. But with similar, the sides are not the same length, but they're proportional. So that's kind of sloppy, but that's kind of but the angles are equal. So we're going to start off by looking at this and notice that this is our sign for similar that we're going to use, and looking at that statement and being able to tell what angles are congruent and what sides are proportional. So here we have our statement, and just looking at that we can see that A is going to be congruent to R, B to S, and C to T. So we're supposed to list all the pairs of congruent angles. So remember, angles are the same. So we can go angle A is congruent to angle R. Angle B is congruent to angle S. And angle C is congruent to angle T. And we can just see that from there. So we have A congruent to R, B to S, and C to T. So then we're going to look at the corresponding sides and write proportions with those. So AB here would be proportional to RS, and that proportion would equal BC, which is corresponds with ST, and that would, and the last side, AC, corresponds with RT. Now we could also say RS over AB, ST over BC, and so forth, and move those around in those orders, but that is our congruent angles and our corresponding sides. Next, we're going to talk about deciding whether or not they are congruent, whether or not two shapes or polygons are congruent. So remember, our two things are that they have to be proportional sides and congruent angles. So if I'm looking at these two menu designs that Tan's working on, we're going to check to see if they're similar. If they are, we're going to write a similarity statement. So first, you always want to check the angles, and we see that all these angles are 90-degree angles. So the angles are all equal. So next, we're going to check to make sure the sides are proportional. So we're going to set up a proportion and check it and see if it's true. So does 12 over 14 equal 10 over 12? Does the proportion, the ratio of the lengths, equal the ratio of the widths? So we're going to cross multiply. So we get 144 when we do 12 times 12, and we're checking to see if that equals 14 times 10, 140. And it doesn't, so these are not similar because the sides aren't proportional. So here we have the same thing. First, check your angles. Angles are all equal, so we're good there. Next, check your proportions. So does the ratio of the widths, 10 over 8, does that equal the ratio of the lengths, 12 over 9.6? So cross multiply. And 10 times 9.6 is 96. And 8 times 12 is also 96. So this is equal. So then they are similar. So we're going to write our similarity statement. And again, we want to make sure we line up the sides and the angles. So we would go A, B, C, D is similar. So there's our similar sign to R, S, T, U. So that'll be the second part. It's just checking to make sure that the polygons are similar. Next, we're told that they're similar, so we're going to solve for our missing variables. When we're doing this, we should get a scale factor from our two sides that are corresponding that have numbers on there. So in here, my scale factor would be 6 to 4 or 3 over 2. So we're going to use that scale factor and solve for our unknown variables. So we can go 6 to 4. So we're doing large to small, and you could do small to large. It wouldn't matter. Just when you put it equal to set up your proportion, you want it to do the same way. So we did large over small. We're going to go large over small. So x over 3. Cross multiply. We know they're similar, so these have to be proportional. So we're going to just solve for our missing variable. So 18 equals 4x, and then divide by 4. X equals 4.5. We can do the same thing to solve for y. So again, we have our proportion, 3 over 2 or 6 over 4 for these two sides will equal, well, now we're looking for the y, so what corresponds with the 8 is y plus 1. Cross multiply again. So 6 times the y plus 1 should equal 8 times 4. So 6y plus 6 equals, so we distributed the 6 to both terms, 32. Subtract 6. 6y equals 26, and then divide by 6. So y equals 44.26, or so 4.3. So that's how we're going to use our similar proportions to solve for our unknowns. All right, I'm going to go ahead and let you work out this problem in your notes. If you have questions, let me know. You should get that A equals 2.4 and B equals 7.2. So the last thing is that if polygons are similar, then their perimeters are also proportional to their scale factor. So if we know the perimeter of the other one, we can use that scale factor to find the perimeter of the second. So here, my scale factor is 4 over 7. And this also is 7, and this is 4. So we're going to look and use that 4 over 7. And let's look for AB. Because if we have that, we can get DC, which gives us that perimeter. So 4 over 7 would equal AB, which we don't know, we'll call X, over 10.5. So cross multiply. 4 times 10.5 equals 7x, and then divide by 7. So 42 equals 7x, and then we divide by 7, so x equals 6. So this is 6, which makes this 6. So this will be 10.5, and notice these three are equal, so these three also have to be equal for them to be the same shape, even though it's really not drawn to scale at all. So the perimeter of each polygon, the perimeter of ABCDE, would be 4 plus 4 plus 6 plus 6 plus 6. So 26. And the perimeter of RSTUV would be 7 plus 7 plus 10.5 plus 10.5 plus 10.5. So 45.5. And that should reduce down to the same as 4/7. Right, so that is our lesson on similar polygons.